This is Chapter 6.4, Special Product Patterns, which will be used in connection with Chapter 5.5, Factoring Special Product Patterns. These examples are from page 316. They are the checkpoint examples. Number 5 is z plus 7 times z minus 7. We're still going to use the table method to solve these. So you're going to have z and 7 and z and negative 7. Go ahead and pause the recording and take a minute to solve. Okay, so we have the table. When you use the table method, z squared, negative 7z, 7z, and negative 49. 7z and negative 7z, which are diagonally from one another in the table, are opposites, which means they are 0. So the product of your two binomials, instead of being a trinomial, is a binomial. Okay, now let me talk. In your product, z squared minus 49, the z plus 7 times z minus 7 is a sum and difference pattern. The product will be the difference of two squares. Z squared is a perfect square because z times z is z squared. 49 is a perfect square because 7 times 7 is 49, or the square root of 49 equals 7. Difference of two squares is what you'll be given in Chapter 5.5, and you'll factor it, and you'll end up with 7 plus 7 times 7 minus z minus 7, z plus 7 times z minus 7. Now we're going on to number 6, which is 3y plus 2 squared. That means 3y plus 2 times 3y plus 2. Go ahead and pause the recording and fill in the cells of your table and the dimensions. Okay, so what we want to draw your attention to on both of these problems, in number 5, it was the difference. It was initially a sum and difference pattern. The only difference between z plus 7 and z minus 7 was addition and subtraction. And when you factor that, it became the difference of two squares. The middle term went away, and you had subtraction separating it. In 3y plus 2 squared, that was the square of a binomial, and you will have a middle term. And the first term and the last term are also perfect squares. You have a middle term that is not a perfect square. So that's a perfect square trinomial. Started out with the square of a binomial and went to a perfect square trinomial. So what is the same with both of these, again, is first and last terms are perfect squares. The difference between the two is one is a binomial and the other is a trinomial. Okay, we're going to go ahead and do a couple of more examples. On page 319, I'd like you to do 43 and 47, and then I'd like you to turn the recording back on. Please try to think about them in terms of the sum and difference pattern, which gives you the difference of two squares, and in terms of the square of a binomial pattern, which gives you a perfect square trinomial as your product. When you're finished, turn the recording back on. Okay, on page 319, number 43, 2x plus 4 times 2x minus 4, you're seeing that the variables and the digits are all the same. The only difference is that one is addition and one is subtraction, so this is the sum and difference pattern. The words come right from what you're seeing. We still are using the table method. So 2x times 2x is 4x squared, 2x times negative 4 is negative 8x, 4 times 2x is 8x, and 4 times negative 4 is negative 16. Your like terms are diagonal from one another. They are opposites, 8x and negative 8x, which means they go away or become 0. Your product is 4x squared minus 16. This is, these two perfect squares, 4x squared and 16, are separated by subtraction, so this is called the difference of two squares. For number 47, you have y minus 3, and you're squaring that. So that is the square of a binomial. Y minus 3 is a binomial, so you're simply taking the square of a binomial. You need to stretch it out a little bit. Y minus 3 needs to be y minus 3 times y minus 3, so you do not make the error of going y squared minus 3 squared, which is 9. That is only part of the answer. Okay, so that is the square of a binomial. We're putting it into the table, y minus 3 times y minus 3. Y times y is y squared. Y times negative 3 is negative 3y. Negative 3 times y is negative 3y. Negative 3 times negative 3 is positive 9. Your like terms are still diagonal from one another. Negative 3y and negative 3y is negative 6y. Please notice that your product is y squared minus 6y plus 9, and that y squared and 9 are both perfect squares. Square root of y squared is y, square root of 9 is 3. The square of a binomial will give you a middle term, and it is called, and so therefore your product will be a perfect square trinomial, because your first and last terms are perfect squares, and it is a trinomial. These two patterns are alike in the following manner. Because the first and last terms are perfect squares, they are different in the following manner. One of them is a binomial and the other is a trinomial. Okay, one of the other things that I want you to notice about the square of a binomial is that that middle term, when you get the perfect square trinomial, is simply taking the negative 3 term times the y term. Negative 3 times y is negative 3y, and doubling it or multiplying it by 2. Negative 3y times 2 is negative 6y. You can always get your middle term in that manner for the perfect square trinomial answer, or when you're solving the square of a binomial.